function is equal ax squared. Final test. Okay, it's another class. Sorry, I'm teaching now. Plus bx plus c. So we studied in detail today that function and their application. Let me split the paper, the whiteboard in two pieces. Okay, one way to express the quadratic function is the classical ax squared plus bx plus c. They look like familiar for you. This is similar to, well, you're familiar because you are familiar with the quadratic equation, but it's different. Now it's function. A, B, and C in general are real numbers. Okay, and this the name of this is standard. A standard form of represent the quadratic function. But we have another form case like that. Is a parenthesis x minus h squared plus k. And this is the name of this is vertex. Vertex form. Vertex. Like that. Vertex form. Why vertex form? Because, you know, somehow this function is a parabola. I don't know exactly if this parabola open down or open up. Let's see after how you determine that. But the most important point is that point. And that point is called a vertex. Vertex. And the vertex coordinate of the point is h, k. Now this h, and this k represent the component of this point, h, k, and similar, you know, to the circle. Remember, h and k. H is the x component and k is the y component. So we study advantage and disadvantage of the two different ways, standard and vertex form. Now, what is most convenient to represent the function in a specific case or not. Okay. Let me see. It's obvious. So let me write 1, 2, 3, 4 aspects or characteristic. Look, number one is if you want to find the vertex, just the vertex. It's obvious. It's much better vertex form because you have in immediate you see h and k. And the standard no, because the only information that you have is A, B, C. But don't worry, because in a few minutes, I want to explain how you determine H and K using A, B, C. I discovered the formula que connecting this parameter. But okay, si es better, it's much better this way. Okay. Number two is determine in what direction open the parabola. So we have two possibilities: up, like that, or down, like that. And the control in what direction open is only determined by A. If A, okay, by the way, A is this parameter, okay, it's exactly the same A. So in both equations, you can see A, and A is the same A. We have no B here, we have no C, we have no H, we have no K, but A is C. Yes, we have the same A. If A is positive means greater than 0. That means okay, our parabola open up like that. Okay, open up. Likewise, or otherwise, if A is negative, open down. Okay? Up and down, like that. Now the control, if you want to discover in what direction open the parabola, you see A. That's it. A is -2, down. A is +4, up. That's it. And very important, number 3, determine the Y-intercept. Remember, Y-intercept is the point when the parabola crosses the Y-axis, Y-intercept, no? The formula, you know, que always is evaluated in 0, no? The formula is evaluated in 0. Entonces, in my opinion, the easy way to determine Y-intercept is using a standard form, because if you plug in 0, so you replace X for 0, it's obvious it's equal to C. That C, this number, is always my parabola de Y-intercept. And similar X-intercept is different. Remember, the formula is f of x equal to 0. Wow, look at that. So you replace f of x for this in standard form is a x squared plus bx plus c equal to 0. Now the thing we are doing in the test number 1, solving quadratic equation, is basically find the x-intercept of the parabola. In other words, suppose we have the parabola like that, boom, boom. This point and this point is the x-intercept, is the solution for the quadratic equation. So let me repeat this idea, que es important. When you solve a quadratic equation, actually the thing we are doing is find the x-intercept of the parabola of the quadratic function, no? Que es sinónimo to say parabola. So the x-intercept actually is the real value of the solution of the quadratic equation represent the x-intercept of the parabola. Sometimes happen, look, sometimes happen, suppose one parabola like that, boom, can never cross the x-axis. Therefore, it's because the solution for this quadratic equation is complex or imaginary. It's synonymous, it's approximately the same. Remember, I repeat again this concept several times. When you're in algebra, try to find something. When you're looking for something and you obtain que es complex or imaginary, that means que do not exist. Okay? This is classic in algebra. Now, Y-intercept no, because Y-intercept is just plugging in 0, and X-intercept is solving the quadratic equation associated with the quadratic function. I don't know if it's clear, but I bring example. This is theoretical, blah, 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 blah. Now, but I bring example to illustrate very well this idea. Finally, number 4, extremely important, is the axial symmetry. What the hell is that? Axial symmetry is a hypothetical imaginary line, vertical line always, que split the parabola into equal parts. Suppose this parabola, quadratic function, and this is the axial symmetry. A split, my sketch is not good, but I guarantee you that this distance and this distance is the same. Okay, axial symmetry. By the way, the equation of the axial symmetry is a vertical line. And I know that the equation for any vertical line is x equal 1 number, and specifically this number is h, because the vertex at that point is h comma k. So basically is x equal h is no variable, h is a number, 2, 3, 4, 5, -1, 0, I don't know. Okay, and this is the equation for the axial symmetry. And what is important? It's important because sometimes we have not too much information about the parabola. It's supposed I know that point, suppose this point is 1,2, hypothetical. 1,2. So I can infer directly this point is, well, see this distance, suppose this is 2, this is 1, this distance is 1, so this distance is 1 in opposite direction, so this is 3. This point, without do anything, I know que es 3,2, using the symmetry of the parabola. Okay, you see, I bring 3 examples to illustrate very well any possibility of the quadratic function. And after I present to you two motivation, no? 2 word problems which contain their application, no? Because in the test, you can find a word problem of the application. But don't worry, in your moment you understand very well. Let's move on to the example. Okay, I suppose you understand this and you reinforce it when you see example. Okay, example 1. Example 1. Example 1 say f of x, function notation, is equal minus 2 parentheses x minus 1 squared plus a. Entonces es given this function. Entonces immediately you recognize, wow, the professor give me the quadratic function expressed in, I don't know si es standard or es vertex form. What do you think? ¿Es vertex o estándar? ¿Vertex o estándar? Vertex. Very well. Entonces, immediately, I can see who is A, who is H, and who is K. Let me compare. I know que vertex form is A parenthesis X minus H squared plus K, no? And you can see, wow, what is A? What is A? A is 2. Es negative 2, no? A is negative 2. It's obvious, right? Look, compare. And H. Oh, H is positive 1. So the same situation, or similar situation que we saw before in circle, que es opposite sign. The reason que es opposite sign is because my equation have a minus. So when you see a minus, it's because H is positive 1. See, I see here plus, a different situation because this plus become like the formula is minus and H is negative 1, it's opposite sign, always is opposite sign. You see in the equation negative, the H is positive. However, K, no. K is the same sign because it's plus, no minus. And when it's minus, opposite, but when it's plus, it's the same. Okay, so we conclude immediately in 1 second que the vertex of this parabola is located at the point 1, in the story, no? At least the vertex part. Okay, in what direction open this parabola? What is the parameter que give me the control? In what direction open? What? O or A? Down. How do you know get down, Jordan? Because A is equal to negative 2. When the A is negative, I know que my parabola, gong, open, down. Super. This is super easy to understand. Everyone understands very well. Okay. Entonces, in my opinion, the vertex form is fantastic to discover the vertex and to discover in what direction open. Well, both is the same. However, what is the disadvantage of the vertex form? Well, when you find the Y-intercept and X-intercept, it's not too easy, like a standard. Okay, let me try, but I try. In order to find the Y-intercept, you allow the function is 0. What function? The original function is minus 2, 0 minus 1 squared, no say. Equal, I don't know. Equal, let me try it. 0 minus 1 is negative 1. Negative 1 squared, positive 1. Is minus 2 times 1 plus 8. Is minus 2 plus 8 is 6. Therefore, the conclusion is the Y-intercept is located at the point 0, 6. Remember, the supposition was x equal to 0, and we get y equal to 6. Okay, this is the Y-intercept. So my parabola when they're doing the graph, because by the way, always, guys, in this question, the fundamental question is do the graph. Do the graph. Do the graph using everything. No omission, any detail. What is the detail? Vertex, important detail. And what direction open? Super important detail. Y-intercept, super important detail. X-intercept. X-intercept is different. X-intercept is f of x equal to 0. Okay, entonces basically, who is f of x? F of x is -2, parenthesis, x minus 1 squared plus a equal to 0. In this moment, we have quadratic equation. We can solve it in any way, okay, you know. In my opinion, the best way is using the square root. The square root method, no? Because somebody, not me, do the factorization of this part. So you can expand if you want, putting a standard, apply the quadratic formula. No, it's okay. It's perfect. You get the same answer, but it's too long. No. Much better. Isolate x minus 1 because I move a to the left. Divide by negative to both sides. This is 4. And finally, square root. This is the idea for the method, square root. The square root both sides. You know very well que square and square root cancel, okay, only x minus 1, and square root 4 is 2, but don't forget plus or minus. This is the only detail that you have to remember. Finally, so for x, this is plus or minus 2 plus 1 equal x. I move this one to the left like a positive. So we have plus 2 plus 1 is 3. And minus 2 plus 1 is negative 1. Okay, entonces, ¿cuál es the conclusion? The conclusion is we have 2 x in a set. Es located at the point 3, 0 and negative 1, 0. Okay? Look, because we're enforcing the situation, the y should be 0. I obtain the x is 3. Now, remember, this is x, this is y. This is x, this is y. Okay, entonces, how many points we have in total in our hand? Well, we have 4. We have vertex, good. We have x in y in a set, sorry, and 2x in a set. I know also que my parabola up and down, and that's it, no? So far, it's the only information that we have. Okay, but I need more. Before I start the graphic, I need to understand the axial symmetry. Axial symmetry is a vertical line always. Axis of symmetry. Always is a vertical line. Symmetry. Why? Symmetry. Pero no la que hay, la que hay. Symmetry. Axial symmetry. Entonces es x equal 1. Because h, remember, we discovered que es 1, no? Look at that. This is h, and this is k. Oh, I copy here. H is 1. So h equal 1. Okay, entonces we are ready to do the graph by hand, no? But of course, I do by hand, and I bring the decimals, I check it with decimals. Because I want to illustrate more interesting idea. Look, let me try to find the rectangular coordinate system I have in my computer, paper. Okay, boom, bam. Okay, there you go. Let me enlarge because it's too small. I'll move here. Yeah, I plot the point. What is the point I have in my hand? Well, I have in my hand the vertex, okay, 1,8. I suppose, wow, this is 7 and 8 here. 1,8. I suppose that the vertex is located here. This point is 1,8. This parabola open, down, I know. Another point I found was the Y-intercept was 0.6. And also, we discovered two X-intercept, que is the point -1,0 here, -1,0 and 3,0 here. 3,0. Okay. And also, well, we have 1, 2, 3, 4 points open down, but no, I don't like that. I need more information. I know that the axial symmetry is a line x equal 1. That's I use my rule. I put my rule and 9 degree like that because it's a vertical line, no? I put exactly here, passing through the vertex. And black color dotted line. This is the convention for the axial symmetry, always. In any book. Okay, this is the axial symmetry. Super. Entonces I can see, wow, using the symmetry property, if we have another point of the parabola here, right? Yes or no? At the same distance. Let me see. This distance is 1, 2 to the right and 1, 2 to the left. This distance is 1 to the left and 1 to the right. This point should be the point 2,6 because the x component is 2 and the y component is 6. Ready. I am ready to do the graph of the parabola. Let me use some green color. This. My parabola, I suppose, guys, using my skill, no good skill, look like that. Oh, it's a smooth curve. Okay. Okay, the parabola never is like that. This is wrong. This corner is not acceptable. It's a smooth curve. Okay. Entonces, this is roughly a sketch of my parabola. Okay.
Real quick.
Go ahead.
How did you get 0.6 or 2.6 again?
Using the symmetry property. Look, I have incompleted the pair. I have that point and that point, and the distance is 2 and 2 because it's the axial symmetry. The axial symmetry is one imaginary or hypothetical line que split the parabola into exactly the same part, equal part. Now, si I know that this distance is 1, entonces using the symmetry, boom, property, this distance is also 1, therefore, this new point is 2,6. Why 2? Because this line is x equal 1, and 1 plus 1 is 2, and the same component y is 6, 2,6. Got it? Super? Okay. One more idea before go to the Desmond. Entonces, en Desmond you see super nice. This graph I do roughly and by hand is the domain range. Domain and range of the quadratic function. This quadratic function specific. Okay, domain is always a real number. Why? Because we have no restriction. A nice function. We have no division by 0. We have no square root. It's quadratic function. Square, no square root. Therefore, the domain is a real number. And also, one way to visualize this idea is a parabola. And this parabola open in both directions and continue forever. Therefore, the domain gets x value is all real number. This branch covers all positive numbers. This branch covers all negative. This is obvious. It's obvious that it's all real number. However, the range, no. The range I can see here, okay, this point, I forgot, that point was 1,8, no? 1,8. So my parabola exists from A to negative infinity, or opposite, sorry, from negative infinity to A. We have no parabola in 9, and 10, and 11, no. So the range is from negative infinity, comma, A bracket. Any question? Any question? Let me recap. Summarize. To do the graph elegant with the color algebra graph, We need to determine vertex. It's more easy using the vertex form, okay? Another possibility another important parameter is Y-intercept, X-intercept. Y-intercept is easy, evaluating 0. X-intercept is more complicated because you solve the quadratic equation. Actually, the X-intercept is the solution, the real solution of the quadratic equation, the quadratic equation. And determine after the axial symmetry can always help me to understand much better the parabola, no? You split the parabola into equal parts and you determine some missing point using the symmetry problem. Finally, determine domain is always the same, always a number from negative infinity to positive infinity, and the range is from, in this case, from negative infinity to A, because A corresponded with the maximum value of the parabola. And this is important, maximum, because up and down, entonces our parabola have a maximum. You see in the optimization problem, some problem, optimization, okay, optimization means in mathematics, find the best solution. Maybe it's maximum or maybe it's minimum, depending the parameter we study. See, for example, you have the profit function in my business, is quadratic function. When you find the vertex, you obtain the maximum value. Suppose another problem in which the function that you have is no profit, it's cost. It's money that you spend in the business. Now, si es quadratic function, I suppose that this quadratic function open up, and you need to find the minimum, que es the vertex, but in opposite direction. So open up, so it's a minimum, no maximum. Do you see another example? I promise you see another example. Okay, let's go to Desmo to see exactly the same problem, but elegant, super elegant. Let me switch into Desmos. Switch into Desmos. Okay, there you go. Now Desmos. You see Desmos? Yes or no? Yes or no? Yes or no? Yes. Okay. Now, example number 1. Look at that. Example number 1, this is my equation in vertex form. The typical point was the vertex 1,8. The y-intercept is 0,6. The x, the x-intercept is 3,0 and negative 1,0. And the axial symmetry, look, axial symmetry I did always in black color using dollar line. How you doing that? You click here, you click and hold the mouse, and you define the color and you define the style. The style is dollar line. See, it's like that solid. See, this is just a period, the line. But I don't like period. I like dollar line or dashed line. Get the same. Okay. One more thing. Important. This inequality represents the range. Look at that. Si I activate this inequality, que es y less than or equal 8, highlight the part in which the parabola exists. In other words, this is the range, because I know that the domain is a real number. Any question? Come on, I want to hear a question. No problem with example 1? No? Okay. Let's do it. Now, example 2. Let me come back to the board. Example 2 in the board. Switch it to the board. Boom, board. Okay, this is the board, right? This is the board. Okay, I want to erase everything. Good. Erase canvas. Okay. Let's move on to the example. The example 2. Example 2. Bring me a new situation. Because, okay, f of x. Example 2. Example 2. Pay attention. Bring me a new situation. Es 3x squared plus 12x plus 5. This is now es expressed en estándar. O sea, es obvio que A es 3, B is 12, and C is 5. I have no idea who is H and who is K. I want to prove what is the relationship, what is the formula que connecting. Entonces I want to prove the formula, pero don't worry for the formula, because we can do that in any particular example if you want, using the complete square, the famous particular complete square that you know very well. Suppose in general, I want to derive the formulas. When you have standard, this is a standard. Yeah, I want to convert to the vertex form. Okay, suppose que I replace f of x for y, because for me it's more comfortable. Yeah, I want to manipulate this in order to convert to this. Okay, what should I do? Well, I propose you bring C to the other side. Subtraction. Yeah, I factor out A. I put, I know que it's no common factor, but I enforce it to be. So it's x squared plus b over ax plus empty box. Empty box. Let me see if I did something wrong. You multiplication this and this is a x squared. You multiply this and this, a cancel, and stay bx. I suppose inside the box is empty, zero. So the answer, the equation stays the same. Nothing change because BC go to the left. So my question is, what is the magic number in this case? Magic number to complete the square. What is the magic number in this case? What is the formula? The magic number.
36.
No. It's a letter. It's a letter. No, it's a letter. It's a letter. So we derive the general formula. In this case, what is the magic number? What is the formula for the magic number? I suppose you remember.
36.
It's letter BA, no 36. In this example, maybe you're right. But no. Okay, forget about example 2 for a moment. I try to derive the formula. That connecting standard and vertex. This is a standard and vertex. What is the formula? What is the formula? Don't worry for the number. The formula is, sorry, K. No, hello, no. It's B divided by 2 squared. Yes or no? B divided by 2 squared. Okay, but in our specific example, B is B over A. This is B. So actually it's no B, it's B over A divided by 2 squared. Something like that. So it's B squared over 4A squared. And this is the number I put it here inside the box. In the box I put B squared over 4A squared. In order to keep the equilibrium of the equation in the left hand side, I put plus something, but no, not the same value. Remember, you multiply by A. So when you multiply by A, this, at least one A is cancelled, no? Entonces es B squared over 4A. And so far we have Y minus C plus B squared over 4A is equal A. Entonces this is ready to factorization because this trinomial is perfect square trinomial. Entonces paréntesis X plus B over 2A square. And this is, remember, is the square root of this guy, no? The square root of this guy is B over 2A because the square root 4 is 2. Finally, Y is equal, so for Y, AX plus B over 2A square plus C minus B square over 4A. Now, this is a crucial moment. It's the most important moment today. You compare this equation that I derived from the standard to get the vertex form. Entonces, this A es this A, no problema. H is this guy. But we get 4 with the sign negative here, and it's positive. Therefore, H is equal minus B over 2A. Wow. This is the most important formula of today, in my opinion. And K, well, okay, K is C minus B squared over 4. Okay. This is one possibility to do. So apply the formula, and that's it. Another possibility is, well, go directly to the, let's do it both ways. In this example, I take advantage. I do it in both ways. Suppose I don't remember anything about formula. Go ahead.
I'm sorry, can you explain that one more time, going from A factorization plus C, and then how'd you get A minus B over 2A? And sorry.
Remember, no, it's okay. Remember, this trinomial is perfect square. And the factorization of perfect square consisted in only one parenthesis because they are twin brothers. This x is a square root this x squared. And this is a square root this. And a square root b squared over 4a squared is b over 2a. Yes or no? Yes, exactly. I write here. And plus because every sign is positive. Okay? Yes or no? Clear or no clear?
Yeah, I did you do a shortcut there instead of doing it?
Maybe you understand much better with the number, not with the letter, because it's a literal equation. Entonces it's confusing. Wow. Okay, let's move on to the example. The example say y. Let's do it exactly the same, but with the number, and maybe it's clear for you. And check it out with the formulas. Si match or no. This is 3x squared plus 12 x plus 5. The first thing you should do is move 5 to the right, to the left. And factorization 3 is x squared plus 4x plus box. Everyone follow me so far? Well, number maybe is easy, right? So what is the magic number in this case? What is the magic number in this case? Please help me. Magic number in this case. Guy?
4.
4. It's obvious que 4. Who is playing? Where come from that 4? What is that?
4 divided by 2 square.
Divided by 2. Exactly. 4 divided by 2 is 2. And 2 squared is 4. Super. This is the classical example. They are a coincidence. Okay, let me put 4 here because the board don't allow. Let me try to enclose here. F4. Carajo. F4. Okay, then what does it? I introduce artificially that 4. So I introduce in order to doesn't affect the equation. I need to introduce plus 12, no? And the other side because 4 times 3 is 12, no? Yes or no? You see or no? Where come from the 12? Okay, now a subtraction is a y plus 7, no? Is equal to 3 parentheses. Look, this is the question now. X plus 2 squared. Yes or no? Where come from these 2? Square root 4. Where come from this x? Square root x squared. And this 3 is the common factor. In this case was this number here. Okay. Now finally, solve for y and move 7 to the other side. X plus 2 minus 7. Okay, I copy my famous vertex form equation. Can look like that. Therefore, who is A? Who is A? A3. It's open, right? And what direction open this parabola? Up or down?
Up.
Up. Very well, because the A spot. Who is H? Compare this equation and this equation. Who is H? Who is H?
2.
2 or negative 2?
Negative 2.
Negative 2. Do you understand why? Who is K?
I don't understand why it's negative 2.
I explained one more time, but I explained 40 times. Okay? I want to explain 41 times for you, miss. Okay? And what about K?
Plus 7.
7 positive or 7 negative? 7 negative or 7 positive?
Negative.
7.
Negative. Very well. Okay. The reason is clear. Please try to remember. In my equation, in my generalized vertex form, I don't know one. I don't create. I only try to understand. Sorry, this is where I forgot. H is negative, but in the original example, 2 is positive. The reason it's positive is because we have double negative. So negative of the formula and negative 2. Therefore, I can infer that H is equal to negative. So what is the shortcut to find in 1 second? In 1 second, no, in half a second. Is, see, in the equation I see positive, it's because it's negative, opposite sign. But in this case, no, because here is positive in the equation, in the general equation. So actually, it's exactly the same. And the vertex of this parabola is located at the point negative 2, negative 7. And this parabola open up. At this point is this point. Any question? Okay, let me try to do using the formula, because in my opinion, I consider this formula is fantastic. Okay, H is equal minus B over 2A. This is a formula. State the relationship between A, B, C standard and HK vertex form. I say that this formula is the most important formula today. Let me try to use it. H is equal minus, the formula have a minus here. Who is B? B in our example is, B is 12, no? B is 12. Divided by 2 times A is 3, right? Positive 3. And 2 times 3 is 6, and 12 divided by 6 is negative 2. Boom! I get the same answer without complete square, using this only formula. And that's it, end the story. Now, in order to find K, I can use in this formula, but I don't like this formula because it's too long. So I prefer doing it that way. Look, let me show you. You evaluate in the original function, in the original case, f of x equal 3x squared plus 12x plus 5. You evaluate x equal minus 2. Is x. In order to find the y value associated with this number, f of x is y. So y, f of x, y, it doesn't matter. It's the same. Y is equal to 3 negative 2 squared plus 12 times negative 2 plus 5. Negative 2 squared is 4 times 3, 12, positive 12. This is minus 24 plus 5. Y is equal, this is 12 minus 24 is minus 12, plus 7 is negative plus 5, so is negative 7. And we get exactly the same answer. Look at that. Negative 7 is K. Negative 2 is this. You see that this is fantastic. No necessarily complete square. Go ahead.
I can't see the number that you scrabbled. What is that number? For the equation y equals negative 12 plus
5.
It's a 5?
Absolutely.
Okay.
You say this? You say that, miss?
Yes.
5. Look, I combine 12 positive minus 24 and negative 12. Just bring down this 5 and negative 12 plus 5. More clear?
Clear.
Absolutely. Okay, entonces now, I don't finish this example. This is just the beginning. The only thing I did, I try to explain different way, blah, 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 blah. But what is the conclusion? The conclusion is you can use complete square. You can, if you want. If you feel strong, you can. But my recommendation is using this formula, and that's it. You have in my hand A, B, and C. Now you compute H like a minus B over 2A. The answer was -2 in this example, no? In other example, another number. I'm plugging in this H is -2 into the function, and you get this is K. This is H. Okay? So far, the only thing we have in my hand is the vertex. If the vertex is located at the point -2, -7. Yeah, I know that the parabola up and down, up. No, up. What is the reason they open up? Because A is 3, positive 3. Okay, let's continue. Let's try to find the rest. What is the rest? Y-intercept, X-intercept. So I want to you pay attention, advantage and disadvantage in between standard and vertex 4. Because at the beginning, my equation was y equal 3x squared plus 12x plus 5. No? If you want to find y-intercept, it's super easy. It's evaluating 0. When you evaluate 0, this part is 0, this part is 0, and the state is 5. So in general, guys, in general, f of x, so y-intercept is always 0, c. The c and the ax squared plus bx plus c. This c represent the y-intercept, always. This is super easy to see in the standard and very, very complicated to see in vertex 4. Otherwise, in the vertex 4, it's super easy to see vertex point, and it's hard to see y-intercept. Okay, let me try now to find the x-intercept. Now, x-intercept is classical. It's f of x equal to 0. And who is f of x? F of x is 3x squared plus 12x plus 5. Put equal to 0, and now we focus into solving this quadratic equation. The solution for this quadratic equation represents the x-intercept. Well, in my opinion, the only possibility we have is solving by quadratic formula, ABC. A is 3, B is 12, C is 5. Plugging into the quadratic formula is minus B plus or minus square root B squared minus 4AC divided by 2A. I copy again one more time the quadratic formula. This is minus 12 plus or minus square root 12 squared minus 4 times 3 times 5 divided by 2 times 3. 12 squared is 144. The answer of that part is 144 minus, this is 6. 4 times 3 is 12 times 5 is 60. And when you're subtracting, it's 84. And square root 84, unfortunately, it's not exact perfect square number, right? But okay, no problem. I understand. I tried to simplification a little bit. I want the answer, well, I want the answer in exact form. But after, when you are doing the graph on the paper, you are doing an approximation, decimal approximation. So, well, it's okay. The answer so far is, 84 is even number, divided by 2 is 42. It's even number again, is 21, it's 3 and 7. Or at least I can see if we have one couple of 2 can represent 1, 2 outside the radical. Therefore, the answer is minus 12 plus or minus 2. This 2 is this 2. And stay inside the radical. 3 and 7 get 21. Divided by 6. Now, we can simplification a little bit because 2, 12, and 6 are even numbers, so you divide it by 2, you have minus 6 plus or minus radical 21 over 3. And this is the exact answer. But answer. But I don't like the exact answer because to do the graph on the paper, I have no idea. Negative 6 plus radical 21. Entonces, minus 6 plus radical 21 over 3. And minus 6 minus radical 21 over 3. Plus or minus, no? So I put in my calculator, my scientific calculator, I determined that this value is negative 0.47. This is decimal approximation using 2 decimal places. Normally decimals using 3 decimal places, but okay. And here it's different. It's negative, so it's negative 3.53. Okay, so we discovered that we have 2 X-intercept. The X-intercept is the point negative 0.47, 0 and negative 3.53, 0. Okay? Entonces, how many points we have in your hand? Well, we have the vertex. The vertex, remember, was negative 2, negative 7, no? This was the vertex. We have the Y-intercept, I put 0.C, but actually in my example is 0.5, no? And we have 2 X-intercept, que is this and this. What is the next idea? What is the axis of symmetry? Axis of symmetry is vertical line, x equal h. In our example, h is negative 2. It's a line passing through negative 2 vertical line. And domain and range. Domain is all real number. But the range, range is a little bit complicated, no? This parabola open up, no? Open up. See, open up like that. The range is from this to positive infinity. And this point is minus 2, minus 7, no? So the range is bracket negative 7, infinity. That part. To positive infinity. Okay. Let me see this much to understand much better my parabola. Okay. Guy, everyone follow me or you are totally lost? Huh? Follow me?
I'm going to be honest, I'm totally lost, so that's okay.
I'll stay after class. So far, so good?
I'm lost.
Yeah, I'm just saying I'm completely lost, but I'll stay after class.
Okay, could you give me some clue what part you are lost?
Yeah, you lost me at breaking the square root of 84.
I never lost you. You lost by yourself. Okay. What part I need to repeat again? Of course, more example. I bring more example. Of course, I bring more example. I am a teacher. I know my job. Okay? This is another point. The point is example number 2 that we are doing. What part, Jordan, please help me. What part you don't understand very well?
When you started breaking down 84 with the square and how you got.
Okay. Well, it's an intermediate algebra. Okay. When you try to compute it, square root 84, you put in a calculator if you want, but it's decimal. If you want to simplification without calculator, you break it down 84. So I discovered that 84 was 21. This is the prime factorization. Are you familiar with the prime factorization? 3?
Absolutely, but I don't break it down like that. I really don't. So that's a new way of breaking down.
No. It doesn't matter the way you break it down. So the factorization is unique, and it doesn't matter. You break it down another way. You break it down 84.
Yeah, I put the 84 in 2, and then I break down the 4 into 2, and then the other 4 into 2.
You divide 84 divided by what number? You divide.
2.
84 divided by what number? Break it down, division. 84 divided by what number you prefer to divide?
2.
By 2. Guys, I explained this in intermediate algebra. This is called algebra. Okay? This is, well, okay. But you guide me. What part you don't understand? 84. You are doing the prime factorization. The prime factorization is unique. It doesn't matter. Suppose que you divide by 21. You divide 84 by 21. It's 4. And 4 is 2 and 2. And 21 is 3 and 7. And the combination is 2, 2, 7, 3, 7, 3, 2, and 2. So the primary factorization, it doesn't matter the way that you are doing, it's the same. Therefore, this is not important. The important is I can see that we have one couple of 2, okay? Any couple represent outside, fly. This is a square root, do 2 times 2 times 3 times 7. This couple of 2 represent like a 4, and a square root 4 is 2. Entonces 2 radical 21. Got it? Got it?
I
Yeah.
I understand how you got 84, but I'm confused about the part how did you get 6 from
Okay.
12
Okay.
to 6. That's
Okay.
the only part I'm not understanding.
Okay. This is easy also, Miss. Look.
Okay.
Look.
I'm
I apply the quadratic formula. And I get this answer, right? It's okay? Now you say,
Yeah.
wow, 12, 2, and 6 are even number. So mentally, you divide by 2, divided by 2, divided by 2, 12 divided by 2 is 6, 2 divided by 2 is 1, invisible 1 here, and 6 divided by 2 is 3. Because I want reduce in lowest term, my answer. Make sense?
Makes sense.
Eso, bueno. Another question. Okay, let's go to decimal. No more. Let's go to decimal. Decimal now. Let me switch into decimals. Decimals. Boom. Decimal now. Okay. Do you see decimal? Not yet. Not yet. Switch it to decimal. There you go. Decimals. Switching. Do you see the? You see it, right? This was the example 1. Now example 2 was like that. Look, this is my equation. This is my typical point I discovered. Look at that. Okay, this parabola open up. The vertex located at the point -2, -7. The x-intercept was a weird number that we found using the quadratic equation. And the y-intercept was 0.5. And this was easy because it's just CFI and the standard. And now domain is, the parabola cover from -7 to infinity. Look, this is my range, because the domain is always all real number. Any question? Any question? No? Okay, one more example. I bring another example. Pay attention. Okay, cancel. Board. Where's the board? What happened with the board? I closed the board. I can't believe it. Okay, don't worry. I open new board. Do you understand that the question that you are doing for me is beyond, is before this class. This is called algebra. We discuss important concepts and simplification, primary factorization. This is intermediate algebra. I suppose you know that. Example 3, guys. Oh, okay. Erase the board. Okay. Example 3 now. Example 3. Example 3 is easy. I suppose you understand much better now. Suppose y equal minus x squared plus.
It's blank.
Okay. There you go. Share window. Can you see now?
Yes.
Yes. Minus 5. See my example 3. I have a question, Sergio. This is the standard or vertex form? This is a standard or vertex form?
Standard.
We have two possibilities, standard or vertex.
Standard.
Standard.
Standard, very well. Entonces, immediate identification, ABC. A is -1, B is 4, and C is -5. Okay, entonces, in what direction open this parabola? In what direction open this parabola? Open up or open down?
Down.
Down, why?
This is -1.
Negative.
Because A is -1. What is negative number? Okay. Suppose that I want to find out the vertex. So in order to find the vertex point, I need to find H and K. So now we can complete the square if you want. If you feel strong, complete square. No, but I do not recommend that. You complete H using this fantastic formula. Okay, it's minus B 4, 2 times A is -1. I can see in my formula we have 2 negative, and 2 negative I know always is positive, and 4 divided by 2 is 2. It's 2. H is 2. And K, easy. You find the Y value associated with the H. This is the X value, and this is the Y value. K is the Y value. How you find the Y value? Plugging in 2 here. Minus 2 squared. Plus 4 times 2. Minus 5. Be careful with the sign. Because it's not the same -2 squared and -2 squared. -2 squared is 4, and -2 squared is, you ignore temporarily this negative, is -4. Okay, do you understand this or no? Sure? Do you understand this idea, right? This is -4, this is 8, and this is 5. Well, entonces -1, because -4 and -5 is -9, plus 8 is -1. Entonces this is -1, y our vertex -1, our vertex is located at the point 2, -1. So I have some information about this parabola. Open down, and the vertex, this point is 2, -1. More clear now? More clear? More clear now or no? Yes. Launa Samson say yes. Now it's clear. The rest is okay? What more information we need? Well, we need the rest. We need Y-intercept. What is Y-intercept? Who help me with the Y-intercept? Without do mathematics. Only using the common sense. What is the point Y-intercept in which? It's -5. Very well, 0, -5. How do you know that? How do you know that? Because I see. See, give me always the Y-intercept. And X-intercept, no, it's more complicated. You take the equation, you put equal to 0, and you solve in this quadratic equation. This is 5. Huh? I mean, right here, it's 5. It's 5. Okay. 5. And remember, A is -1. One more time I write. B is 4, positive 4, C is negative 5. What are the formula? Minus B plus minus square root B squared minus 4AC divided by 2A. 2 times A. Entonces, minus 4 plus or minus square root 4 squared minus 4 multiplication by negative 1 multiplication by negative 5. Wow, a lot of negative we have here. Divided by 2 times negative 1. This is 16. And we have 1, 2, and 3 negative. This is what is the total sign after the 3 negative?
Negative.
Negative 20. And 16 minus 20 is negative 4. Wow. And what happens square root negative 4? What is the answer square root negative 4? You pass the test number 1. The square root negative 4 is
imaginary.
Imaginary, do I? And since imaginary, what means that? What means when you're in algebra?
There's no y-intercept.
Exactly. These intercept I try to discover do not exist. Do not exist. So this parabola never crossed the x-axis. Wow, why? I don't understand very well why, but okay. Okay. Entonces, axial symmetry. Axial symmetry is vertical line, x equal h, and h in our example is 2. Look at that. This is h and this is k in the vertex. Okay, ready. I go to the decimal to do fast. You see, because see, I do it in my hand, I do it in decimal, I do it twice because I lost time. Okay, let me try. Boom. Boom. There you go. This is example 3. Example 3. Oh, look at what happened in the example. The vertex is at the point 2, negative 1, and the parabola open up, open down. Entonces es obvio que never cross the x-axis. Entonces the only point I have in my hand is 0, negative 5, que was the y-intercept. Pero using the symmetry, remember that distance is the same to this distance. See, this distance is, this is 0, this is 2, this is distance is 2, and 2 to the right is 4. This point, using just the symmetry, no mathematics, symmetry, and common sense, is 4, negative 5. So the same y component, negative 5, but the x component is the same distance from the axial symmetry to both points. And you determine 1/3 point, que is the okay. Do you understand this or no? Confusing, very confusing. Very confusing. This test is hard or is easy? Huh? Let me see. Let me go to the board. Okay, there you go. Okay. Okay, let me explain, because the rest I need to prepare to teach to you was the application. The application is a little bit more complicated. Let's do it for the next time. Okay, let me try to condensing the information that we have so far. Okay, I want to tell you again the story at the beginning. No, but no with detail. Quickly, look. We have 2 different ways to express the quadratic function. This way is called standard. And we have another semicolon, que is y is equal a x minus h squared plus k squared. And this is called vertex. form. Okay, ya I present two different ways. The first way is good to find, for example, the Y-intercept because it's 0,6. That number, C. 5, -5, whatever. The second is countable when you want to find vertex because the vertex is H, K, and H is this number and K is this number. Both are countable to find the direction because A controls the direction. When the A is positive, up. When the A is negative, down. And A is common parameter in both. So it's the same. In order to find, what's the problem? See, the professor or the test, give me a standard. I need to find the vertex. Well, I use my formula. H is equal minus B over 2A. This formula allows me to find H when you have A, B, C. No, C, no. C don't participate in the formula. And in order to find K, you evaluate the function NH. That's it. In the story. Entonces, you complementing the point to do the parabola. We need at least, what's the minimum point that we need to find in order to compute do the graph of the parabola? At least 3 points. Suppose another example, we have vertex. We have 1 point here, get the Y-intercept. We have no X-intercept. We have the axial symmetry. And you determine this point because this is the axial symmetry and this distance is exactly the same distance. I do my parabola like that. This is the importance of the axis of symmetry. Okay, sometimes give me some clue to determine some more point using the symmetry. One more, okay, domain is always a real number, always. And the range, no. Because in this case, the range is from this number, suppose that this number is -1. This is the range. The range is bracket, no, parentheses, minus infinity, comma, -1 bracket. Because it's the lower bound and minus infinity, and the upper is -1 in this example. Guys, do you understand the idea? Yes or no? Come on. Yes or no? Yes or no? Okay, we continue next time doing application. So I suppose that you know the quadratic function. I suppose that you know how we are doing the graph of the quadratic function, vertex, y-intercept, x-intercept, axial symmetry. And from this information, we are doing application in the word problem. And the test, we have one question, two questions, do the graph of the quadratic function. One is in standard and another is in vertex form. And you have 2 more questions about the word problem of the application, optimization using the quadratic function. Any question? No? Okay. Thank you for your attention. You can leave. Andreina, thank you. Okay. Pleasure, as always. Let me disconnecting the record.